Hi, hello. Welcome to Electronics 1 Zener Diode tutorial 1B. Clear that? Okay. So this continues from my previous video, tutorial 1A. So for this question, they've changed the value of the resistance of RL to 470 ohms, so load resistance to 470 ohms. So again, the same thing. We need to know whether the Zener diode is on or off for this condition, 10 volts Zener diode. So let's say 20 volts here, 220 ohm, and without the Zener diode connected, we would like to know the values of voltages and current across the resistor. So using voltage divider rule, okay, we could find now the voltage across here. Okay, that would give you a 13.62 volts. That case, using KVL, we can know the voltage across here, that minus that we get 6.38 volts. And your current here, you will get 29 milliamps. So the current is same at all locations, 29 milliamps. Now the next step is by placing the Zener diode itself in the circuit. So now you place the Zener diode in the circuit, 10 volts Zener diode, and we want to know whether it is on or off. There's a requirement, that is Vz should be smaller than VRL, then the Zener diode is on. Otherwise, it's not satisfying this equation, then the Zener diode is off condition. So for this case here, we have here 10 volts Vz is 10 volts, voltage across that is being clamped to 10 volts, and you have a VRL here 13.62 volts. Okay, so that satisfies that case the Zener diode is on. So if that Zener diode is on, then you will have a current that's passing through here, IZ. And now the complication starts in the circuit, where all these parameters that you calculated is no more valid. The voltages and current that you have calculated is not valid because this is on. That will climb this to 10 volts. So when this climbs to 10 volts, this is parallel. So then you will have also another circuit here. I just draw another circuit. Then you will have all the other parameters will be all different because you have clamped it to 10. Okay, so if I draw this way, and you have now your Zener diode, and your Zener diode's function is to clamp the voltage here to 10. So in that case, this voltage here is 10, then the voltage here is also clamped to 10 volts. So your VRL is 10 volts. This is 470 ohms. So that case here, this is clamped to 10. So this 13.2 volt, it's not more valid when you put in the Zener diode and it is in on condition. Okay, so now that will be here 220 ohms. So what will be the voltage across here? This is 20 ohms. So the voltage across here was no more 6.38, because when this is being clamped to 10, then automatically this is also been clamped to a voltage that is not 6.238. With 6.38, then you plus volt, you will not get this location 10 volts, and this is 6.39 volts, then you plus you won't get 20 volts kVA. So that case, immediately now you could know that this voltage here is now going to be 10 volts, because this plus this, then you get 20 volts. So that case, what will be the current here? Okay, the current here. So that is actually your high total current. Okay, it's going to pass through here, and then it's going to break into two portions, here and here, of IZ and IRL. Both that two currents will be plus, then it's going to be the current of this of I total here. Okay, so we look at that answer there. Okay, you get your current here, okay, using this rule, that is your ERIR. Okay, so you know you don't know the current, but you know the resistor and the voltage, 10 volts and 220, then you can get the current. So the current you get is 45.45 milliamps. Okay, so that will be a total current that is passing through here. And now we want to know IRL. What will be the current IRL? So again, you can use the same rule, VIR, and you want to know what is the current here. You can know by the voltage that is across this resistor, that is 10 volts, and also your resistor value 470 ohms. And you know what is the I that is passing through here, that is your IRL. Okay, so your IRL is 21.28 milliamps. Finally, you want to know what is IZ. If you want to know what is IZ, you know the total. So these two plus, you should get this. So this minus this, then you get IZ. And IZ is 24.17 milliamps. So your output voltage here will be 10 volts, and the current is 21.28 milliamps. So that will be your final answer for this particular voltage regulator circuit. So hope this was helpful. Thank you.